All right. We are going to do a little bit of work with multiplying exponents. And in order to figure out what the rule is, we're going to talk about what each of these look like in expanded form. So, for example, this first one here, we have x to the second power multiplied by x to the sixth power. So, what that really means, especially if we're thinking x to the second power, it really just means that we have x multiplied by x. We have two of them. So that's these ones here. And then we are multiplying by x to the sixth power. So times x times x times x times x times x and times x. Now, all we have here is multiplication. So really, we could write all of these without the parentheses, and it's all just multiplication. So what we have is x being multiplied 1, 2, 3, 4, 5, 6, 7, 8 times, which we write as x to the 8th power. All right, let's do another example. A to the 4th multiplied by a to the 10th. So a to the 4th, a times a times a times a multiplied by a to the 10th. So again, I can put parentheses around them, but I don't have to because all of these are just getting multiplied together. So now I have a times a times a, 4, 5, 6, 7, 8, 9, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 A's altogether, which really is just a to the power of 14. So, if we think about this rule and what this would look like for any given numbers, now if we look down here, I have x to the power of a times x to the power of b. X can be any number, a can be any number, and b can be any number, and this will work every time. So, if we take a look at the exponents, in that example, we have 2 times 6, and then we got an exponent of 8, and then a to the 4th times a to the 10th, and then we got an exponent of 14. So the rule is, when we're multiplying, we take our two exponents and we add them together. So that will be our simplified answer. So we could have done x to the power of 2 plus 6, which really is x to the power of 8. Same thing over here, x to the power of 4 plus 10, which really is x to the power of 14. Perfect. Now let's think about what happens when we have a power of a power. So, we have c to the 4th power to the power of 3. So this exponent here is impacting what is on the inside of the parentheses. So c to the 4th power is c times c times c times c. So there's 1, but this exponent 3 here tells us we need 3 copies of this. So I'm going to take this. Now I have 2 copies. Now I have 3 copies. So altogether, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is really c to the power of 12. Let's look at another example. K to the 5th power to the 4th power. So again, we have 4 copies of k to the 5th power. So k to the 5th power looks like this. K times k times k times k times k. So there's one copy, but we need 4 of these. So there's 2, 3, 4. So all together, if I count those up, I have a group of 5, 10, 15, 20, k to the power of 20. Now the same thing works when we have more than one term in the parentheses. So inside here, I have x to the second power, y to the third power, z. So when you don't see anything in between, we can remember that it's each of those multiplied together. And then we have all of that to the power of 2. So just one of these, x to the power of 2 is x, times y to the power of 3 is times y, times y, times y, so 3 y's. And then the z doesn't have an exponent, so it means that I just have one of them. So there's one copy of everything that's in the parentheses. Now I'm going to take that and I am going to take another one of those. So all together, I have 1, 2, 3, 4 x's. Ooh, sorry. Getting ahead of myself. I have 4 x's multiplied together. So I have x to the power, I keep forgetting to write the x to the power of 4. And then I have y, 2, 3, 4, 5, 6. I have 6 y's, so y to the power of 6. And I have 1, 2 z's, so z to the power of 2. And there is my simplified answer right there. Now I can't combine the x, the y's, and the z's because they have different bases. Remember, when we're looking at exponents, we have the base, which is our bigger number, and then the exponent, which is the small number. So when we think of exponents, we want to think of the base as like what we're making a copy of, and the exponent tells us how many times to make a copy. So if we take a look at all of these, looking at my exponent examples from above up here, I have exponent of 4 and 3, and I got 12. And then I had 5 and 4, and I got 20. And I had 2 and 2, and I got 4. 2 and 3, and I got 6. And then 2 and nothing. But when we see that, we can just think that I have a 1 there. So I have 2 and 1, and I got 2. So the rule when we're talking about power of a power is we take the exponents and we multiply them. X to the power of a times b. So if we look back up here, we can see that c to the power of 4 times 3, well, 4 times 3 is 12, which is what we got. Same thing over here, k to the power of 5 times 4, which 5 times 4 is 20, which we got. And then the same thing here, except for we have to make sure to multiply each of those individually. So when we're talking about x, we have x to the power of 2 times 2 multiplied by y to the power of 3 times 2 multiplied by z to the power of 1 times 2, which again, x to the power of 2 times 2, which is 4, multiplied by y to the power of 3 times 2, which is 6, and z to the power of 1 times 2, which is 2, which is what we got. So no matter which way feels most comfortable, whether you put it out into factored form or you use the shortcut rule, this is how you know how to get the answer.